Today we'll be doing this part under probability known as a tree diagram. It's actually one of the concepts many people actually getting it wrong, but I'll try my best here to explain it. Tree diagram. So it has two types of the diagrams, but they are all called tree diagrams. They are events. We can have two events like this. Then it continues. We draw it like this. So this is the first one, whereby we're having two events. Let's say it's M here and it's F. We have two events, male and female. But it can happen that we have three events like this. Okay, this is an event. These are two events, right? But we can have three events like this. So even here, it will actually give us three events. Each and every branch in this tree will give us three events, as you can see. So we might be given two events, or we might be given three events. So it's very important. Just check what are they talking about, how many events are they talking about. It's one and the same thing as the Venn diagram. It talks about probabilities. So we check the number of events. All right. Let's actually do this example. Let's say we have three blue pens, and we have maybe four green pens. They use them to moderate the papers. Then we have two, for example, red pens. Yes. Then these are events, if I can put it that way. We have three of them. We're talking about three things here: blue, green, and red pens. So we're going to have that second tree diagram having three branches. I hope it makes sense. But the 3, 4, and 2 are favorable outcomes. But when we add all of them, they must give us 9 as what? As our sample space. So this 9 is a sample space. But 3, 4, and 2 are just favorable outcome. Meaning if we have favorable outcome and a sample space, we can have probability. It can be 3 over 9. Maybe all of them, they are actually inside a box. So the probability of blue pens can be 3 over 9. Probability of green pens 4 over 9. Of red pens can be 2 over 9. So but we must actually represent this information in a tree diagram. So it's very important for you to check first how many branches are you going to have. Here we're going to have 3 branches. Then each branch forms 3 arms. I hope you understand that, or 3 branches. Okay, let me just start here by showing you the first 3 branches in this tree diagram. So we have 3. Why? Because we're talking about 3 different pens here. I hope it makes sense. Then each and every branch, it will form 3 branches. So it's blue, green, and red. So the blue pen will form 3 branches, as you can see. I'm trying my best here. And even the green one will form 3 branches. Also the red one. All right, so we write B here, green, red, and write the red BGR. So this is the type of our tree diagram, but we're not done because we must actually put that information in this tree diagram. Okay, so what you must know is that they can say draw a tree diagram without replacement. You must know what are they saying when they tell us to draw a tree diagram without replacement. So it's very important. That's what we're going to explain right now. Okay, so when they talk about without replacement, what you must know is that, for example, let's say you have three balls. You write them down. The three balls, the simple space will be 3. But if you pick a ball, you write it down and you keep it out. Now there are only 2 balls that are left for the next draw. Therefore, when you draw the tree diagram on the first 3 branches, before they can actually result to produce the other 3, you write their favorable outcomes divided by the sample space, as is what I'm going to do right now. Now, if you choose one ball, the one that you chose, now when you actually count whatever that you are left with on your bag or whatever it is that you stored your balls in, what you must know is that you will no longer have 3 over 3. It will be 2 over 3. Why? Because you took it out and you didn't actually replace it. I hope it makes sense, but I'm going to actually do that right here as we're going to do this question. So what you must know, without replacement, you pick a ball, you write it down and you keep it out, meaning the probability now will be 2 over 3. But when you talk about replacement, you pick a ball, you write it down and you put it back, so nothing changes there. I hope that makes sense, but I'm going to actually do this with us so that we'll be able to understand what I'm saying, because this is actually a bit confusing, or it's a bit confusing concept under probability, but let's just try to do it. But you must know, with replacement, you pick a ball, you write it down, then you put it back. So this one will be without replacement. You don't actually put it back, you keep it out. Okay, now what we know here is that these ones, when we add them, they give us a sample space of 9, right? Therefore the sample space is 9, but the probability of blue balls, it will be 3 over 9. I hope it makes sense. Now let's say you put all these pens inside a box or inside a bag. All of them, when you count them, there must be 9, but there are favorable outcome, because we can say we have 3 balls. So how many balls do we have? How many pens do we have? We have 9 pens. But inside this, how many blue pens do we have? We have 3 blue pens. So it will be 3 over 9. That's the probability of the blue pens. Then inside this bag or inside this box, how many green pens do we have? We have 4 green pens. 4 over what? It will be 4 over 9. This is just, we haven't actually chosen anything, we haven't picked anything, we're just writing the probabilities. I hope it makes sense. Then how many red pens inside this bag of 9 pens? We have 2 red pens, therefore it will be 2 over 9. These are just probabilities, but now we need to actually draw our tree diagram without replacement. So what we're going to do now, without replacement, it means that when we pick a ball, we won't actually return it, so the sample space will now be disturbed. I hope that makes sense. We will have 8 as the sample space. Why? Because we are taking out balls without replacement, meaning we won't be having 8, we won't be having 9 sample space, but we'll have 8 now. I hope that makes sense. Why? Because we are not putting it back, we are keeping it out. I hope it makes sense. So here we have B, we chose B. Therefore when we take one blue pens, we'll now have 2 blue pens, but those other ones will remain as they were. I hope it makes sense. It will be 4 here and it will be 2. Why? Because we didn't actually choose them. I hope that makes sense. Then here we are choosing what? We are choosing green. Now when we choose green, how many green pens are we going to have? We're going to have 3, but those other ones will be the way they were. Why? Because we didn't choose them. So we're going to have 3 here, and we're going to have okay, here it's 3 because the blue pens are not touched. Then here we're going to have 3. Why? Because we removed 1 green pen. And over here we're going to have 2 blue pens on the red pens. I hope that makes sense. So that's very, very important. Then we come to the R. We're going to take 1 red pen and we'll not actually return it. We'll keep it out. Therefore, the blue pens won't be affected. We'll have 3. Then the green pens won't be affected. We'll have 4. Then what about the red pens? They will be affected. We'll have 1. I hope it makes sense. Then for you to see that this tree diagram is correct, because there is a secret that you must know that will actually help you to see if your tree diagram is correct or incorrect. But this is how our tree diagram looks like, or this is how we represented that information in our tree diagram. So for us to see that our tree diagram is accurate, this is what you must do. You multiply the probability of BB and BG, BR, and so forth. But I'll already show you in no time. But this is important, guys. So what you're going to do now, so check if it's without replacement or with replacement. So you're going to multiply B, you're going to write it here. BG, you're going to write it right here. BR or RB. Then BG or GB, so on the same thing. GG, GR, RB, or let me just write BR. RG, RR. Then you leave it like this, because there might be question that they might ask that you must actually have something like this on your book. Okay, so for you to see that this is correct, what you must do, you take the probability of B, the original probability, times the affected one, you write the answer, and you take this one again with G, B, and R, you write the answer, 4/9, and those ones is GB, GG, you write the answer, GR, you write the answer, BR, you write the answer, RG, you write the answer, RR, you write the answer. Then these answers, you add them, they must give you 1. When they give you 1, just know that your tree diagram is correct. I hope it makes sense. That's very, very important. So the most important thing, know the difference between with replacement or without replacement. I hope it makes sense. Very, very important. So we are given this information. They want us to answer these questions, but we cannot answer them without having a tree diagram. So this is what they've given us. They want us, before we can actually be able to answer these questions, we must know how to represent whatever information they've given us in a tree diagram. So here, what they gave us, they said 2 learners are selected at random. So this is telling us that we must use without what? Without replacement. I hope it makes sense. We must use that restriction. Why? Because they selected 2 learners, then they didn't actually return them. Now we have 10 boys and 12 girls. So 2 learners were selected at random. That selected random is telling us that we must actually use without replacement for us to be able to determine 10.21 and 10.22. Hope it makes sense. So 2, they are becoming specific, then we're selected at random. That's what is usually showing us that we must use without replacement. Okay, we have 2 branches here. Why? Because we have two genders. We don't have three genders. Two genders, boys and girls. I'm not sure if there is a plural for gender. We cannot actually write it like this, but we have two of them. Okay, so this arm here, it's for boys and this one is for girls. Then this one will result into two branches or arms. I don't know what they are called, but let's just say branches. I just know how to draw it. Okay, so this is the type of our tree diagram. So it will be B and G, boys and girls. Okay, now the total here of these two gender, I'm not sure it's gender or it's genders. I'm not sure if gender has plural form. Okay, we have 10 boys plus 12 girls. Then when we add all of them, they give us a sample space of 22 boys and girls. All right, now the probability of the boys, it will be 10 over 22 before selecting them. Remember, it's without replacement, but here we cannot actually change anything. Why? Because we haven't selected any. So it's 12 here over 22. Then here we're going to write 21. Why? Because we selected and we're not actually returning back, but we're taking these two learners out. Then it will be 21. Let me just write it down here. 21, yes. 21 and 21. Now we're choosing the boys. We're now going to have 1 that is taken out, therefore it will be 9. Then this one will remain, right? Because we didn't take them. This one will be 10 and this one will be 11 here. Why? Because we are taking 1 girl. I hope it makes sense. So we can see that we took 1 boy and 1 girl. I hope that made sense. So this is our tree diagram. But it's very important for us to indicate so that we'll be able to solve 10.21 and 10.22 that we have BB, BG, BG, and GG. I hope it makes sense. If you understood the first one, you'll understand this one. So BB, boys and boys, boys and girls, boys and girls, and girls and girls. Alright, now let's try to solve 10.21. 10.21, they are both girls. So these two here, they are both girls. GG. They want the probability. So these are probabilities. We'll actually multiply them. 12 over 22 times 11 over 21. But if they wanted they're both girls and they're both boys, we're going to multiply these ones and add them with the product of 10 over 22 and 9 over 21. I hope it makes sense. So 10.22, 1 is a boy and 1 is a girl. So it's BG and BG. We're going to take this 10 over 22 multiplied by 12 over 21. Then we add it with what? With 12 over 22 times 10 over 21. I hope it makes sense. These two, going to add them with the first one, the first probability of BG. Alright, so it's going to be 10 over 22. What am I writing? 10 over 22 times 12 over 21. Then we add them with the other BG, which is 12 over 22 times 10 over 21. 10 over 21. Then your answer will be 40 over 7. You can over 77. You can write it in decimal form if you like. So this is how you're solving this. But what made me to have this, to draw it like this, to use replacement without replacement, is because of this selected at random. Two learners were selected at random. I hope it makes sense. So try to use past question papers to draw a tree diagram.